Let us give me some list of formulas for solving problems on thin cylindrical shells. Here I would be writing a number of formulae, and based on that we are going to solve problems on thin cylinders. So here the topic is formula list for solving problems on thin cylinders. So here I would be writing some formulas which are very important from the subject point of view and as well as for solving the problems. So the first formula which I have, that is hoop stress, or you can say circumferential stress, both are same. Hoop stress is given by PD upon 2T, the first formula, and the unit will be Newton per mm square. Here what is P, D and T, that I would be explaining very soon. Next, longitudinal stress, sigma suffix L is equal to PD upon 4T. Unit is again Newton per mm square because these are internal stresses. Next, shear stress, or you can say maximum shear stress. I will write it as tau max is equal to PD upon 8T. Apart from these formulas, we have hoop strain, that is E suffix H will be equal to, in simple terms it will be hoop stress divided by Young's modulus minus mu, that is Poisson's ratio, into longitudinal stress upon Young's modulus. This whole formula, it can even be reduced into one form, and that is PD upon 4 TE 2 minus mu. So this is the hoop strain formula which we have. Previously we have written hoop stress formula. Next, after this we have longitudinal strain. E suffix L will be equal to longitudinal stress upon Young's modulus minus mu into hoop stress upon Young's modulus, and that can be reduced to PD upon 4 TE 1 minus 2 mu. So here we have written some formulas, and based on these formulas we would be solving the problems. So likewise I have prepared this list of formula for thin cylinders. Even when you all will be solving the problems on thin cylinders, you all should keep this formula list with you, and whenever the question is solved you have to write these formulas, and that would be like a recollection. You would be recollecting the formula and writing it in the problem. So now with these formulas, let us start solving the problems. And here I have my first question. The heading is problems on thin cylinders. The first question is, a closed cylindrical vessel made of steel plates 4 mm thick with plain ends carries fluid under a pressure of 3 Newton per mm square, full stop. The diameter of the cylinder is 250 mm and length is 750 mm. Calculate longitudinal and hoop stresses in the cylinder wall and determine the changes in diameter, length and volume of the cylinder. Full stop. Take Young's modulus 2.1 10⁵ Newton per mm square and mu is equal to 0.286. This mu, it is also called as Poisson's ratio, or you can say the ratio of lateral strain to linear strain, that is mu. Now the problem is given in front of us. Whatever is specified in this problem, we will write that in the form of a data. This is our first problem on thin cylinder. Here it is given a closed cylindrical vessel made of steel plates 4 mm thick. So the thickness is equal to 4 mm with plain ends, carries fluid under a pressure of 3 Newton per mm square. So internal pressure of the fluid is 3 Newton per mm square. Next, the diameter of the cylinder is 250 mm and length is 750. So small d internal diameter 250 mm and length is equal to 750 mm. Here the question is, calculate longitudinal and hoop stresses in the cylinder wall. The first part, we have to calculate how much is longitudinal stress, hoop stress. Next, and determine changes in diameter, length and volume of the cylinder. So I have to find out how much is the change in diameter. I'll say that it is delta D. Next, how much is the change in length, delta L, and change in volume. Here they have given Young's modulus 2.1 into 10 raised to 5 Newton per mm square and Poisson's ratio mu is equal to 0.286. So with these data available, let us try to get the solution for this problem. The first question is longitudinal stress. Now, in the data, first let me explain it to you that how the cylinder will look like. Here we have a thin cylinder which carries internal fluid. The diameter of that thin cylinder is the internal diameter. I will call that as small d. Then the length of this thin cylinder is denoted by L. The thickness is given by small d. Now this thin cylinder would be breaking into two parts based on either it is circumferential or hoop stress. The breaking would be different. So first, since we are considering longitudinal stress, I will say that since longitudinal stress is given by sigma L suffix L is equal to PD upon 4T, where P is the internal pressure and in this problem P is given as 3, the internal diameter is 3, internal diameter is 250, actually it is 250, 4 into thickness is 4 mm. So if I calculate from this, I will get longitudinal stress as the answer which I have calculated. It is 46.88 Newton per mm square. This is the continuation of the problem. So here we have first answer of longitudinal stress. And here I can show you all the diagram that how longitudinal stress will break the cylinder. So in longitudinal stress which is developed, it will be breaking if the stress value exceeds the resisting capacity of the cylinder walls, it would be breaking the cylinder into two halves along its length. So that is the effect of longitudinal stress. Now let me calculate hoop stress. Now since hoop stress is given by sigma h is equal to PD upon 2T, therefore hoop stress is equal to P is 3, diameter is 250 divided by 2 into thickness is 4 mm. So from this hoop stress value comes out to be 93.75 Newton per mm square. This will be the second answer. And how the cylinder would be breaking? Because of the internal pressure developed, there are chances of the cylinder to burst in such a way that is perpendicular to the circumference. That is, instead of breaking the thin cylinder lengthwise, it would be breaking along its diameter. So here we have hoop stress and longitudinal stress. Answer 1 and answer 2 is completed. Next, the next question in this problem is, we have to find out change in diameter. For change in diameter, we would be calculating hoop strain. I'll say that since hoop strain is given by E suffix h is equal to hoop stress upon Young's modulus minus Poisson ratio into longitudinal stress upon Young's modulus. Therefore, I will write down hoop stress is equal to, taking 1 upon E as common and putting the value of E, which is 2.1 into 10 raised to 5. Here I have taken Young's modulus common. Into bracket hoop stress. Our first answer of hoop stress was 93.75 minus mu is 0.286 given and longitudinal stress was 46.88. So from this, if I calculate hoop strain, it will be 3.83 into 10 raised to minus 4, and this hoop strain can also be written in the form of diameter, that is, it is equal to the change in diameter upon original diameter. So here the question is to calculate change in diameter. So I will say that therefore delta D will be equal to 3.83 into 10 raised to minus 4 multiplied by original diameter, and the value in this problem is 250. So from this I will be getting the change in diameter, and that answer is 0.096 mm, our third answer. If we see the next question in this, here we have to calculate the change in length. For change in diameter, we had seen hoop strain. For change in length, we will see longitudinal strain. Now I will say that since longitudinal strain is given by it will be E suffix L is equal to longitudinal stress upon Young's modulus minus mu into hoop stress upon Young's modulus. Therefore, longitudinal strain will be equal to Longitudinal stress, the answer was 46.88 divided by 2.1 into 10 raised to 5 minus mu is 0.286 into hoop stress is 93.75 divided by 2.1 into 10 raised to 5. So from this I will be getting longitudinal strain value as 9.55 into 10 raised to minus 5, and strain doesn't have any unit. So this longitudinal strain, I can say that it is also equal to change in length upon original length. Change in length is delta L, original length is L. So the question is to calculate change in length. I will say that delta L is equal to longitudinal strain into the original length, and that is 9.55 into 10 raised to minus 5. Original length is 750 mm, that's the length of the cylinder. So from this I will be getting delta L value as 0.0716 mm, my fourth answer. Now in this, the fifth part was to calculate volumetric strain. I can say that volumetric strain is given by E suffix V is equal to hoop strain plus longitudinal strain. Therefore, E suffix V is equal to hoop strain value, it was 3.826 into 10 raised to minus 4 plus longitudinal strain 9.55 4 into 10 raised to minus 5, and that will give me volumetric strain as, I would be getting one answer here of volumetric strain, which I can say it is equal to change in volume upon original volume. And the question is to find change in volume. I will say that it is volumetric strain multiplied by the original volume. So it would be volumetric strain into the original volume is pi by 4 into diameter square multiplied by length. So from this I will be first putting this volumetric strain value here, and I would be calculating the whole term, and my answer of change in volume comes out to be 31.69 into 10 raised to 3 mm cube, since it is the change in volume. And this is my fifth answer. As we see in this question, there were 5 things asked. First, longitudinal stress, we have given the value 46.88. Then hoop stress, the value was 93.75. Change in diameter, change in length, and change in volume we have calculated, and with this the first problem on thin cylinders is over.